So we're going to take a quick look back to your last assignment here and say, okay, what's this stuff that we've got going on here with increasing and decreasing? And I'm hoping by showing off a little with colors here, you can kind of see what we're up to. So let me get this typed in. Okay, so I take a quick peek at kind of what the graph's going to look like. I'm like, okay. Now I need to get all this information over here to the left so I can have a fairly accurate graph on this. Now again, I might get fortunate. Maybe I'll find an x-intercept or two by looking. Okay, maybe not. But here's what I would do while I was here. Any values that I saw in this chart that had fit on my actual graph, I'd use those, because the more points I have, the more likely I am to have an accurate graph. So let me go ahead and get the points that I see on here plotted. So I can kind of come back here for a second, and I kind of see what this is going to look like, and I could make a fairly accurate sketch this way. But since I need my x-intercepts, or I need my zeros, right off the bat anyway, might as well go find them. So I see 3 of them, so I'm going to go ahead, I'm going to get those found first. So again, just to the left, which would be underneath my x-axis in this case, and then just above, so I trap this in. So I'll get my 2 x's there. So I've got one intercept at negative 1.790. Scooch this over for a second here. And I'm going to do that for each of my places where I see an intersect with x. Now again, when I get to this one, my cursor, when it's left bound, it's going to be above because that's still to the left. What I have here, I'll get below, so I'm trapping it in. So I'd have 0.110. And then I got one more there. So I'll use my 0 in my menu. Oops, that's too far. So to the left and to the right. And again, which we hilariously learned on Thursday, again, when you see E with those, that's basically heading you into 0, because that's just going to be decimal points. So 1.670. Now, I still need to find my max and min, but I'm going to go ahead and I'm going to plot these two. So again, we're just trying to shoot for some accuracy here. So I get those. Now I still need my local max and min. We know, since we're seeing these going forever up and down, we're going to see a lot of infinity when it comes to our increasing and decreasing. But we still can find our local max and our local min. So let's see. Max is first. We'll do max. Back to our calculate. We're going to find the maximum. We'll get our cursor guy over here. And again, somewhere to the left, somewhere over here. We'll hit enter. Back over to the right somewhere. Again, as long as I trap that point in. So basically it looks like we're at negative 1.7 for our max. And then we'll do the same thing, except we'll find our minimum down here at the bottom. Anywhere along here is fine for my cursor. All these places are to the left. To the right, anywhere on the right's all good. And that looks like that's going to be at 1, -5. So that gives me a couple more points to play with. Negative 1.7 I already had. 1, -5 I already had. Well, all right. So now, here's what I'm ready to do. I'm ready to go ahead and do my sketch of my graph. And when we're doing increasing, decreasing, this is the part where I'm saying, okay, when I'm looking at the graph and I'm going from left to right, where are my values going? Up. So as I'm doing this, I'm going, okay, my graph is going up, so my y values, which is basically what we're looking at with increasing, decreasing, are going upward. So this particular one starts at negative infinity, because we're always doing these from left to right, starts at negative infinity until I get up to my maximum point here, which is going to be, well, when x equals -1. Now this is going to be the part for some of you that are going to be like, wait a minute. Even though I'm looking at it as far as my graph going up or down in value, when I'm doing increasing, decreasing, I'm still looking at in regards to x.
Because even though we're seeing it just go down, we do know that it's slightly moving to the left, so it's eventually going to hit negative infinity.
Right. So when it gets to here, you notice it starts to go downward. So starting at -1, and I'm going to talk about which symbols to use here in just a second, it starts to go down until I get to here at my minimum, which is at an x value of +1. But when I get to my minimum, you notice it turns around, it starts going back up or increasing. So then, if you have more than one, you use your union symbol. We're starting again at 1, and it increases forever after that. Now the symbols, never for infinity, because infinity is always going to be a parenthesis, but for these and these, they're interchangeable, because I don't want a gap, but there's no distinct way to say, well, this one should be, you could have brackets on these and parentheses on these, or vice versa, as long as one of them has it, because you have to include 1 and -1 somehow.
So do we have to say it's increasing left to right?
No, that's just me explaining. So when you're kind of looking at it, you're like, well, which direction am I looking? You're reading it like a book. As you start to see your graph happen, is it increasing at the start or is it decreasing? So we're all starting in the same place.
So this was an assignment?
Yes.
Okay, that's what the 6.4 said.
Yes. Does that fix things for you a little better? Good. Okay. Uh-huh. Sure. Okay. Let's pop number 2 up here. Okay, so we've got -1/4 x to the 4th plus 2x squared. All right, let's see what this looks like before we even start here. Okay, now this one, bless you, this one's going to be a little more interesting. So I still am going to do my other stuff before I get to increasing, decreasing, just to make sure we're accurate as we can be here. And I got a little bit fortunate this time because I see I get at least one of my x-intercepts this way. So, all right, let's do a little plotting here. Let me move this over. So at -3, I'm a little below -2. And then at -2, I'm at 4. -1, we're almost at 2, 0, 0. And then it reciprocates back up and then back down. Okay. So here's one thing I notice. I notice now that one of my x-intercepts I can get from when I just did the chart. I know one of them's at 0, 0. But I haven't figured out these other two yet. So let's go ahead and figure out where they are. Again, to the left would just be underneath. And to the right would just be above. So I've got -2.830. And it looks like it's going to be a reciprocal. I'm pretty sure it's going to be 2.83, but I better be sure. So again, left is anywhere above, because I'm still to the left of my point. And right's just going to be below. And it was what I thought. It's 2.830. So I can get those dotted in. And let's check on our maxes and mins. Now this time I got 2 maxes. And my min, I basically know is going to be at 0, 0 because I can see that already. But we'll double check. We'll make sure that we're being accurate and doing our due diligence here. So okay, let's go back over here. Work on my max here. So to the left, and to the right. So my max is at -2, 4. Which I already had as one of my points. So you're like, so can I assume that's going to be 2, 4? I wouldn't blame you if you did, but I'm going to be sure. So to the left of it, to the right of it, anywhere over here, 2, 4. All right. So I've got all my information now to go ahead make a pretty good sketch of what that looks like. So now when it comes to increasing, decreasing, again, we're going to look at this from left to right. So when I start with this graph, as I'm starting here on the left, I'm going upward. So it's going to start increasing from -infinity until I reach my first maximum. And again, we're looking at x values, so it'll be at -2. Then, let me switch colors up here. Maybe. There we go. So then it turns, and starting at, oopsie, -2, Harty is your first one. -2. Starting at -2 and going until I hit this point at my minimum, 0, because then it churns again and starts increasing. So it starts increasing again from 0 until I get to my next maximum at 2. And then it turns one more time and heads down forever. So it goes from 2 to infinity. No, not -infinity. From 2 to infinity. So we just go from left to right, but again, all the values in here are x values. Because when you talk about anything from left to right, well, left to right is talking about x's. We're just kind of following the graph along up and down as it goes from left to right. And sometimes just doing the color thing can even help out somewhat. Okay, is increasing, decrease. Yes, ma'am.
I don't understand when you use a parenthesis or a bracket.
Okay, those are, I want to be careful when I use the word interchangeable, but it's true. For instance, on this one that we just did, I could, because I need to make sure that I include this -2, this 0, and this +2 somewhere within the solution. So I can't just use parentheses for all of them because then I'd have holes at those places. But I also can't use brackets for every single one because then I'm kind of double dipping. So what I'm trying to say with these is I could take this exact same increasing, decreasing, still have the parenthesis on my -infinity, but I could do this just as easily and then switch these guys and they both would work.
Okay, so it doesn't matter.
It doesn't matter. The only one that is for sure is infinity and -infinity are always parentheses. The other ones are interchangeable.
All right, thank you.
Uh-huh. Number 4. All right, let's flip over here. Okay, so when we get back here, now it's in a little different of a format, but it's still working. to be able to identify the zeros back on 4, I would just take each of those quantities that I have, those sets of parentheses, and set them equal to 0. So that would get me zeros at 2, -1, and -3. So again, those zeros are going to be x-intercepts. So then, to get our other information and to make our graph more accurate, we would simply pull up the old calculator. Go ahead, we'll get this typed in to get us some more points to work with. And again, the biggest thing a lot of time with this is just making sure you're accurate and you don't get like signs flipped around or anything like that. So I can see where my zeros are going to be, and I'm going to see them on the screen too, because whenever I see a y value of 0, that's an x-intercept. And again, I'm just going to get a few more points in here so I can be as accurate as I can be. Oops. Make sure I don't have any more points to play with. So as I get those jotted in, oops, wrong button. So I'm like, okay. So this comes up, and down, and back up again. So I can get my sketch in. Now, here's an interesting twist. A y-intercept. My y-intercept is going to occur when x equals 0. So my y-intercept would be at 0, -1.2. And it only goes through the y-axis once, so I only have one. And then again, I'm going to have a max and I'm going to have a min. So we'll go ahead, we'll get those calculated, and then we should be good to go here. So again, we'll trap that first little hill in. So we're looking like we're at -2.12 and 0.81. And then our min is over here. At about 0.79, -1.64. And that's all we're basically looking for. So 5 would kind of work the same way. That square just means you're going to hit that same point more than once. And that can happen sometimes with these. And that's all we got working. Sure. So again, all we're doing, is there any particular spot in it that's giving you a dilemma?
Just the increasing.
Okay, so if we're just talking increasing, decreasing here, we'll take a look at the graph on here and we'll kind of talk about what would happen. So x to the 5th minus 5x cubed plus 4x. Okay. Now that one, that kind of looks funky. Because you're like, now, if I were to go and take a peek at this one, let me make sure I typed everything. Oh no, that's why that looks weird. I have no minus sign on there. Like, that doesn't look like the graph I was expecting. Again, another advertisement for, I was gonna say, another advertisement for making sure that you are careful. Okay, x to the 5th minus 5x to the 3rd plus 4x, okay. That's better. Okay, so in general, let me do this so we can kind of get us on the track here. And I'm gotta make sure I do all this stuff because again, otherwise it's not going to work. So let's try this out. it's not. There we go. Holy cow, check out all the zeros. Okay, so x-intercepts, there are a load of them. So I've got negative 2, 0, negative 1, 0, 0, 0, 1, 0, 2, 0. That's a sight we don't see very often. But it does get me all of my zeros and all of my answers, so okay. So when I get back to my graph, it looks like I got 2 maxes and 2 mins. So let's get this guy trapped in. So I've got one at negative 1.64, 3.63. And I got another one at 0.54, 1.42. And then we'll just get my mins in, and then we should be ready to roll here. So negative 0.54, negative 1.42. And last one. .64, negative 3.63. Okay, so if I get those plotted in here too, then I'm ready to get that crazy looking thing drawn in. And once I have that, when I go for increasing, decreasing, it looks like I'm starting at negative infinity here again. So I'm going until I hit that first maximum. So at negative 1.64, and again, parenthesis bracket, just choose whether you're going to use them on increasing or decreasing. They're interchangeable. So then I look and I'm like, okay, so then at negative 1.64, it starts decreasing until I get to my first minimum at negative 0.54. Okay, we'll get that closed up. So then my increasing starts again at that negative 0.54 and heads up until I hit my second maximum at 0.54. Then it stops. Then I get ready to head down again. Holy cow. So I start at 0.54 till I get to my second min at 1.64. Lock that up. And finally, I start at that 1.64 and go up and up and up forever and ever and ever. So I mean, the biggest thing with that is just keeping patient enough to get yourself an accurate drawing, so when you do get to your turning points that you're going, well, I know it goes up and up and up, but I'm really not sure where it stops. That's why I've got to know my maxes and mins on things like that. And that's how that is going to work. So here's the game plan that we're going to use here. I'm going to get a small start into the 6-6 notes today. We'll finish them up tomorrow. Yes, sir.
So I forget. For a y-intercept, that means they're crossing the y line, right?
Correct.
So there's only going to be one usually.
Very true. So what we'll do here is we are going to get you started on this, and we'll be able to get at least a little bit of the homework started this way on it. No graphing to play with here. So we're going to talk a little bit today about how we can use synthetic division to help us do a little bit more with as far as factoring goes and finding solutions. So for instance, if we're given a function and asked to use synthetic substitution or division to find f of x divided by x minus 4, remember, if you're given a binomial term to divide by and you're using synthetic division, you have to change the sign on this. So once you do that, then you're just going to use the coefficients. And we're going to go ahead and do this using synthetic substitution. So again, you pull your first term down, then multiply them together and add down, multiply and add. I'm just looking a second to make sure I'm not doing something goofy. Multiply I should just keep quiet and see if anybody catches anything right now. Anybody see anything wrong here so far? Or am I good to go? Oh, everybody seems to think he's good. Okay, let's keep going. We'll find the oh, wait a minute.
There should be an x squared.
Ah! Now see, this is when we get going along. This can get to be an issue. Right, whenever we're doing these, we go down 1 step or 1 degree each time. 4, 3, oh, no 2. Gotta have x squared in here. 1, 0. So instead of running this way, what should my initial problem here look like? Good. 3, negative 2, because that's x to the 4th, x to the 3rd, x squared, x, and my constant term. And you'll see in a minute, we would have caught ourselves even if we did make that error before. But again, it's one of those things to watch out for. So 4 times 3 is 12, add down, 40, add down, multiply, add down, ooh, big answer. Multiply, add down. And again, if I wanted to get out this solution, I'd sit there and say, okay, so I'd have started with x to the 4th, so I start with 1 less, x to the 3rd, x squared, x, my constant term, and there's my remainder. Now, here's where we're actually going to start seeing how I can use this whole synthetic division, synthetic substitution to actually, take care of something, solve something. Now find f of 4. In other words, take this expression, and everywhere you see an x, replace it with a 4. When you get that cranked out, let me know what you get. $662. See, this is where we would have been able to see where our error was before. Because what happens is the relationship, the value of f of x, f of h, f of whatever you want to call it, is the same as the remainder of when we're dividing by the binomial. Okay? So again, the value of f of x, or f of whatever number you have, is equal to dividing by the binomial and finding its remainder. So if you were ever asked to just find the remainder of something or find an f of value, you can do it either way and get to the same solution, whichever you think is going to go faster for you. Now, we still want to pay attention to what we're being asked to do. For instance, if it says use synthetic substitution, synthetic division, to find f of 4, don't just plug in 4 right now. Okay? Follow the instruction, and then we can kind of play with this a little. So f of 4 just means the 4 is what's going to go in the box. Now, we won't mess up again here. 3, 2, 1, 0. Okay, no zeros this time. And then again, we're just going to roll through, bring the first term down, multiply, add down, multiply, add down, multiply, add down, and whatever that value is on the end is the value of your function at that particular value. Okay, I don't even have to go back in and put in x squared, x, just it's the remainder value on the end, you're done. Keep it simple, keep it simple, keep it simple. All right, so number 2, I'm going to divide by 4. What is my lineup here going to look like? 3, negative 4, 2? 3, 0, negative 4, 2. Pull that 3 down. Multiply. Add down. Multiply. Add down. Multiply. Add down. F of 4. I think the goal is here. I think we're going to get through the front of this. We'll have to play with the back tomorrow, but let's keep playing here a little.
Okay, so the back is, this is homework page.
Yeah, and I'll tell you which ones we're capable of knocking out here before you get yourself set here. I just want to take a look at a couple more here. I'm going to go past 3 and 4 for now because they're repeating the same idea. You're just plugging in negative 3 instead. So number 5. Show that x plus 5 is a factor of x cubed plus 2x squared minus 13x plus 10. Then find the remaining factors of the polynomial.
So is this for homework check 12? Or is this
First one on 13.
Okay, I was going to say.
Yep. Notice they didn't say x equals. It says x plus here. My x equals value would be negative 5. So that's what I need to divide by. And then again, no holes, that's good. Drop the first term, multiply, and add, multiply, and add, multiply, and add. Okay? That's how we just showed that x plus 5 is a factor. It's a factor if there's no remainder. So we're good as far as that goes. But this time we're not quite done. Started with x to the third. So I got x squared minus 3x plus 2. I need to factor this. But again, the nice thing is these are always going to be diamonds. And an easy one at that. Multiply to 2, add to negative 3, okay, is negative 2 and negative 1. So if you're asked to find, so here are my remaining factors. So that was my second question they wanted me to find. And then again, to show that this is a factor of this, that's proven by showing that's a remainder of 0. And the only thing left that kind of goes with this, as we kind of scooch up here, given a polynomial and one of its factors, find the remaining factors. Basically, they want us to do the same thing that they did up here. They give us the first one, which here means my x value is going to be 2. So that goes in my box. 3, 2, 1, 0. Okay, no zeros again. And I'm just going to run through a synthetic division. And again, it's just multiply and add. Should get that 0 on the end if it's truly a factor, and it does. And then I need to factor the quadratic that remains. And if for some reason you'd find something that doesn't factor, first double check your work. Second, if that doesn't work, you can always go back and try to use the quadratic formula, but you shouldn't have to with these. So a positive 4 and a negative 1. And it says write as a completely factored polynomial, which means here's my first two, and I'll bring that one they gave me at the start back down and put it in. And that would be my completely factored out polynomial for this one. Because if I were to multiply all this out, I would get the original polynomial back, is what we're attempting to do here. Let's see. Let's do this. All right, let's flip over for a second here. We're going to look at those problems, the actual problems up the top, tomorrow at the start here. But just a reminder, okay, this will be homework check 13. This is going to end up being the first assignment in that. And I want to double check on the ones that we're capable of doing here so far, because we won't have to clean up much tomorrow, but I want to make sure what we're good with and what we're not. Okay. We're good on the 3 through 7 part. We are good on 8 and 10. We are good on 12 and 14. Well, hey. Well, all right, and we're good there too. So basically, you're good on this first part. So we're only going to have a small handful of problems left tomorrow to even try to clean up and deal with. And that won't take long at all. But again, make sure your focus is on the check, because that is still coming tomorrow. But again, this assignment is not on there.
So I was able to, make sure I did it all right.